Okay. So we have discussed in the previous lecture these logical equivalences. Okay, so these are the various rules which are available in the propositional logic, like the rule of commutativity, rule of associativity, De Morgan's law, bidirectional elimination law, implication elimination, distributive law. Okay, so all these rules you should be able to remember, because you will see that these rules are useful in inferencing mechanism. Okay, they are not the difficult rules to remember. Okay, De Morgan's law you are already familiar. The commutativity and associative, they are actually the simpler. Okay, the distributivity uh, you know already earlier. Okay, and in the last class also we have talked about all these things, what is validity and what is this satisfiability. Okay, so I need not to repeat all these things earlier. Okay, so what is the main thing? We want to represent the facts using the propositional logic. Okay, and we want to apply the inferencing mechanism, okay, to deduce, to discover new facts, okay, based upon the knowledge base we have. So we have a knowledge base, okay, that is written here KB. KB stands for knowledge base. Okay, so we have a knowledge base in which we have a number of facts, and each and every fact we can represent using the propositional logic. So in this, in the end of this uh, lecture, we will see some examples. Okay, how we can solve a particular example. Okay, using the concept of propositional logic. Okay, so what are the different kinds of proofing methods? Right. So, what is the purpose of these proof methods? That we are given a knowledge base in which we have some number of facts, and we want to discover new facts, okay, from the knowledge base, right? So they can be divided. Proofing methods can be divided into two categories. One is the one is the method which is actually using inferencing rules, and another is known as the model checking, right? So we will discuss, we will mainly focus on the method number one, which is actually going to use the inferencing rules. Okay, so you will see there are actually uh, three methods, three kinds of techniques in this application of inferencing rules. One is called the resolution. Resolution is a method, and we have another methods like forward and backward chaining. So forward chaining is one technique, and backward chaining is another technique. So okay, so it means we have three techniques. One is resolution, another is forward chaining, another is backward chaining, which actually apply the inferencing rules. Okay, so we will see in the coming slide what are the different inferencing rules for the propositional logic. And the second proofing method is actually called model checking. Okay, so in case of the model checking, okay, the idea is that we assign truth values to different propositional atoms. Okay, and there are some methods like WOTSET, DPLL. Okay, so we are not going to discuss the methods which are coming into this category of model checking. We will restrict ourselves to the method of resolution, forward chaining, and then the backward chaining. Okay, now what is the normal form in case of the propositional logic? So basically, there are some inferencing methods like the resolution, okay, which require that you convert your propositional statements into the normal form. Okay, that is actually called the CNF, conjunctive normal form. Right. So what is the idea? The idea is that we are given a knowledge base KB, okay, and we want to prove that the statement alpha can be derived from this knowledge base KB. It means that if all the facts in the knowledge base are true, then alpha is going to be true. So in other words, we can write down it like KB logical and not alpha is unsatisfiable. So if we prove that knowledge base and not alpha is going to be unsatisfiable, it means that alpha can be derived from the knowledge base KB. Right. So the idea is that when we apply the method like the resolution, we need to write first KB and negation alpha into the equivalent CNF form. Right. So what is this CNF? This is actually known as the conjunctive normal form. So whatever propositional statements we have, okay, we will follow a algorithm that we will discuss in the coming slides that will convert the statement into this CNF form. And then after we can apply the method of resolution. Okay, so see in case of the CNF, we are actually having clauses. Okay, we are having actually many clauses, and these clauses are containing the propositional variables, okay, which are connected with the logical OR, okay, which are connected by the disjunctions, and the clauses are connected by the conjunctions, right? So we know that any knowledge base we have, okay, it can be easily converted into the equivalent CNF. And if there are k number of literals per clause, then it is called KCNF normal form, right? So sometimes we see that there are some methods like resolution, okay, which require you to convert your knowledge base statements into the equivalent conjunctive normal form. And there exists a specific procedure, there exists a specific algorithm that can convert a knowledge base into the CNF, right? Are you getting me, all of you? Yes, all of you are getting me? Somebody need to respond so that I know. Yes, all of you are there. Please respond me.
Yes, sir.
Okay,
Yes, sir.
fine. Okay. So what is the procedure of the conversion to this CNF? The procedure is listed here. Okay. So we apply all these rules, okay, in the order. So if we have a bidirectional operator in our propositional statement, so we will apply this rule so that we can convert this bidirectional into a implication operator. And once we have the implication operator, then we apply this rule to remove the, to eliminate the implication operator. And then we use this double negation, okay, then we use this double negation so that we can push the negation symbol inside the literal, inside the propositional statement. Okay, then we use this De Morgan's law. Why do we use De Morgan's law? Because we know that the clause contains a number of propositional atoms or variables which are connected by disjunction. So if I want to convert this logical AND into OR, I need to use this De Morgan's law, right? Then if we require the distributivity rule, then we apply this distributive rule, okay, so that we may get the equivalent CNN. Okay, so all these things are actually required to be done, okay, so that we may convert a particular propositional statement into equivalent conjunctive normal form statement. Okay, so what are the different rules of inference available in case of the propositional logic? Okay, so you will find one of the very important inference rule that is actually called the modus ponens. Okay, so you will see that many inferencing methods, they are actually using this modus ponens rule. So what is this modus ponens? If you have alpha implies beta, which is true, and you have alpha is true, then it will infer that beta will be also true. That is known as the modus ponens rule. So you will find that this rule is applicable many of the times when we derive new facts from the knowledge base. Okay, we have other rules also like and elimination. So we know that if alpha and beta are true, if alpha and beta is true, then of course it means that alpha is going to be true. So you know that if alpha and beta is going to be true, this is going to be true in case alpha is true as well as beta is true. So it implies that alpha is going to be true and beta is going to be true. Okay, and we have another rule, that is the and introduction. So if we have alpha and beta and if both are true, then of course alpha logical and beta will also be true. Or introduction, so if we have alpha true, if alpha is going to be true, then alpha logical or beta is going to be true irrespective of the truth value of beta. Then we have another rule, that is the double negation elimination. So negation of alpha, it means that if negation of alpha is going to be true, then it means that alpha is going to be true. Then we have the implication elimination. If alpha implies beta is true, okay, it means that negation of alpha and beta is true, right? Then we have the unit resolution. Okay, if alpha or beta is going to be true and negation of beta is true, it means that alpha is going to be true. Then we have the resolution rule. If alpha or beta is true and negation of beta or gamma is true, then alpha or gamma will be true. So in this case, you will see that beta and negation of beta, they will be removed and we will have only alpha and we will have only gamma. So that is called the resolution rule, right? So all these are actually the inferencing rules available in case of the propositional logic. So you will find that most of the time in case of the resolution, this is applicable, and otherwise you will see that modus ponens is the rule. You will find most of the time it is going to be applicable to the method of inference. Okay, so any question into this? If you have any confusion, you have any doubt about this rule, you can ask me. Yes, Ravi, any question from your side? Yes, everybody is listening? Yes, Shraddha?
Yes, sir.
Okay, are you there? Are you
Yes,
listening?
sir.
Okay, okay. It is fine,
Yes,
everybody, I
sir.
think. Okay, I think you all of you are already familiar with these rules. Okay, okay. So we will see one example. So you see example here. So what is that? We are given the statements. If John is not married, he is a bachelor. So if John is married can be represented by P, and he is a bachelor is represented by Q. So you know that the if then statements, they are actually written using this implication operator. So I can translate it into the negation of P or Q, or implies Q. Then I have another statement which is given that John is not a bachelor. It means that I can represent it negation of Q, right? And therefore I need to prove that John is married. So I need to prove this statement using the two statements. So I have represented it using this propositional logic, negation of P or Q, negation of Q and P. Now we are given that negation of P implies Q is true, right? So if I remove this implication by the rule implication elimination, so I will get this. So I will get negation of P or Q by using this implication elimination. Okay, and this double negation of P means P, so it can be written as, I can use double negation of P. I apply this rule double negation elimination. So this negation of P or Q will be equivalent to P or Q, right? So it means that P or Q is true, and we are also given that negation of Q is true. Okay, so this is true and this is true. Now I apply the unit resolution rule. Okay, so here I see the Q and here I see the negation of Q. So they will cancel out using this rule of unit resolution. Okay, and I will get P. Right. So this P is what? The conclusion I get. So I can say that if negation of P or Q is true and negation of Q is true, it implies that the P is also going to be true. Okay, now if we check the validity of this statement, you know the validity, what happens? Okay, so if the left hand side is going to be true, in that case the right hand side is also going to be true, right? So if we check the validity of this, we can assign the truth values to P and Q, which is true and false, and we can create a table and we will find that it is going to be valid statement. Okay, so this is the proving using the rules of inference, right? So we know the inferencing rules, okay, and we convert the facts into the propositional statements, okay, and we apply the various inferencing rules and we prove it that the statement can be derived or not, right? So you may be asked to solve a question using the rules of inference, okay, but the problem in case of applying the rules of inference is that you need to remember all these rules of inference and you practice it, okay, then only you will be able to solve this problem, right? Another problem is that if we talk about the computer, whether the computer can apply these rules and find out whether the statement can be derived or not, so it is also not possible, right? So we will see there are other methods like resolution, okay, which can be automated by the computer system, okay, for such kind of inferencing, right? So any doubt into this? Is there any doubt, anybody? Any doubt, anybody? No doubt? Yes, Rishi Mishra, any doubt? Are you able to see my screen?
Yes, sir.
Okay. So I hope this is clear. Yes. Okay. So what is the resolution inference rule for CNF? Right. So you know, in case of CNF, I have a number of clauses. So you see here that I have one clause and I have another clause. Right. So in one clause I have A or B or C. In another clause I have negation of it. Okay. So this is one clause and this is another clause in my CNF. So according to this resolution inference rule for CNF, if I get a propositional symbol A and I get a negation of that propositional symbol, then they will cancel out. So A and negation A, they will cancel out and I will get only B or C. Right. This is actually the resolution inference rule for CNF. Similarly, if I have one clause like this, A or B or C, and I have another clause negation of A or D or E. So this A and negation of A will cancel out and I will get all the other things, B or C or D or E. That will be my conclusion, or that will be my inference. Similarly, if I have A or B, one clause, and I have another clause negation of A or B, so A and negation of A will cancel out and I will get B or B, and you know that B or B is actually going to be equivalent to B, right? So this B is the conclusion I will get. So this is what the resolution inference rule, this is actually known as the resolution inference rule for the conjunctive normal form. Got the point, everybody? Is there any question into this? No question? Okay, fine. Okay, so we will see first what is this method of resolution, which is a inferencing method in propositional logic. So the important thing about the resolution is that it is a method that can be automated, by the computer system. So it is basically a automated theorem proving method, right? And it is important to artificial intelligence, okay, because the logical agent can apply this resolution method, okay, and can derive new knowledge from the given knowledge. So it helps logical agent to prove new theorems, means new statements, propositional statements, and all these statements when they are derived, they are actually going to be added to the existing knowledge base, right? So that's why the resolution is a important method. Now, what is this resolution algorithm? How does it actually going to work? So what happens that we are given a knowledge base containing a number of facts, and we are given an expression or a statement which we want to prove that it can be derived from the given knowledge base. So first we will be negating this expression, okay, and we will be adding that into the existing knowledge base, okay, and we will try to see whether we are finding a contradiction or not. Okay, if we find a contradiction, it means that negated statement is going to be false. It means that the original statement is going to be true, right? So we are given a knowledge base, we are given a statement, and we want to check whether the given statement can be derived from the given knowledge base. So for that, we will negate the statement first, and we will add it to the knowledge base, and we will see that whether there is a contradiction if we add this statement. Okay, so if we find a contradiction, it means that negated statement cannot be added to the knowledge base. It means that the original statement that we have is going to be true, right? This is actually known as the resolution algorithm. So it is a simple algorithm. It does not require much important work to be done, okay, before applying this algorithm. But one thing is that when we apply this resolution algorithm, we need to convert all the propositional statements into the conjunctive normal form. Yes, any question into this? Anybody? Any question into this? Is there any question from anyone? Yes, any question from anyone? The strength has reduced to 24. Why? Why many people have left? Let me check who are there. Yes, is there any problem in understanding this concept? Yes, Rishi Mishra. Rishi Mishra, is there any problem? Ritik Manchanda. Ritik Manchanda. Namishahan.
Yes, sir.
Is there any problem in understanding this concept?
No, no, sir.
Where are the other people? The attendance has dropped to 23.
सर नेटवर्क इशू होगा.
Okay. Okay. So we can represent this resolution algorithm like this. So we have a knowledge base. Okay, and we want to show that alpha is a statement that can be derived from this knowledge base. So we will prove that knowledge base and negation of alpha is going to be unsatisfiable, right? So this resolution algorithm is capable to generate all the new statements from the knowledge base. Okay, so two things may happen. One is that we find that P and negation of P, which is unsatisfiable. Okay, it means that we can entail the query if we find that knowledge base and negation of alpha is going to be unsatisfiable. It means that alpha can be derived from this knowledge base. If we find no contradiction, then there is a model that satisfies the sentence and we cannot entail. It means that we cannot entail alpha. It means that alpha cannot be derived from the knowledge base, right? So this is actually known as the resolution algorithm. So we will see one example, one practical example, how to apply this resolution algorithm, okay, to find out the whether a particular alpha can be derived from the knowledge base or not. Okay, so we come to this example. So we are given a knowledge base. Okay, so what is given to us? So we are given the facts. So one statement we are given is the coyote chases roadrunner. If roadrunner is smart,